good afternoon, anyone in this beautiful rainy day across New Zealand. Thank you for attending my session, Power BI and Power Platform Data Flows. And a special thanks to Hamish, Rami, and everyone who was involved in setting up this event. The weather is quite nice for this event, but of course it's a lot of work, so I appreciate all your support and help, and thanks for the opportunity, of course. So a little bit about me. I'm Reza. I'm a Microsoft Regional Director, MVP. I work at Red. I'm a Power BI consultant, trainer, and in my day-to-day work, I work with a lot of people who are building Power BI solutions. So I help them in their challenges and solutions. I'm also author of some Power BI books, which you can go to Red website. Some of them are available for free to download. You can get a lot of materials over there as well. Now, talking about these sessions, just one thing before I get into the content. If you ever have a question, just put it in the chat window. There would be some points in the middle of the presentation that I'll see if we can discuss some of the questions. So at that point, I will ask you to unmute yourself. But for now, if you have any questions, put it in the chat window. I'll keep an eye over there too. OK, so talking about data flows, first you need to know what is data flow, what it is used for. So I always start with this example that imagine you are using a table in multiple files. Now, I said files because in Power BI environment, everything is in a file, a PBIX file. In Power Platform environment, I don't know what you call it, Power Apps Solution, Power Apps Form, whatever you might call it. Let's say you are using one table in multiple places. How do you do that at the moment? In talking about Power BI, imagine this scenario. Let's say I've been a report developer, sales team in my organization asked me to go and build this report and dashboard for sales, and I went and prepared some data. I connected to the system, source system. I imported some of the data, such as customer data, product data, sales information itself, something like date table. So I populated those and put that together and build a model, the relationship, calculations, visualizations, everything, and deliver it to the sales team. Now, after a few months, let's say another team like the warehouse team comes to me and say, we want also a report. And I go and build a new report because this is totally different from the previous department that was for sales. This is for totally different type of people, totally different information. So I go and build a new file. In this new file, I have some data tables that are not in the first one, such as, for example, warehouse tables, such as inventory movement tables. Now, I also have some of the data tables that is similar to what I had before in the previous file, such as product tables. Now, I might have spent a lot of time to prepare that product table. That product table might be, let's say, coming from 2-3 Excel files. I combined them together. One of them might be product, another product category, another product brand, product color. So I combined them all together to build one like fully fledged product table. And I use that in the sales PBIX file. Now, in the new file, in my inventory file, I have to do that all over again, right? Which I'm not really going to do that. So what I normally do is I can go to the first file. In Power BI, we do all the transformations using Power Query. So I'll go to the Power Query editor. I'll copy that script, Power Query M script, and I come to the new file. I paste it, and I have the product table, right? Easy. Now, the problem, however, is that when I copy that code into here, now my source code is in two places. If I ever want to go and change that in the first file, I have to remember that I also have it in another file. So let's go and change it over there too, right? I don't have a single version of truth, single version of source code for my files. Now, this is just two files. Imagine what if I have like 10 different files. Imagine if I have like 2-3 different Power Apps application also using that table, right? So if I want to have really a table shared among multiple files, ideal would be that table sitting in one place and the data transformation for that table, the data integration for that table to be done in one place, one single version of the source code, and all other places to use it. And that is what Dataflow is helping us to do. Dataflow actually came with that promise of helping us to do our data transformation as a separate layer. So what Dataflow is? Dataflow is a Power Query process that runs in the cloud independent from Power BI. In this example, I call it a lot Power BI data flows but we also have data flows in Powerapps Portal. We call it Power Platform data flows. Dataflow also exists in Azure Data Factory. Over there, it is called wrangling data flows. It is like in a lot of places. So I normally prefer to call it Power Query data flows because this is using the engine of Power Query. It connects to some data sources. It applies some data transformations, whatever actually you want that data to be transported based on, and then it loads it into a destination, no matter if you are using it in Power BI, in Power Platform, or anywhere else. That is why I don't want to call it like Power Platform data flows, Power BI data flows. Now, I'll talk about what that destination is, but the engine itself is using Power Query. Power Query is a powerful engine for doing data transformation. You have a really nice graphical user interface that you go and select the transformations you want. You import data from like more than 80 different types of data sources. Most of the transformations are graphical. You don't really write a script. However, if you want to write a script, there's a powerful language behind the scene called M, which you can write complex data transformations with that. That is the engine of data transformation. Now, where the output of Dataflow is stored, there are two options at the moment. It might change in the future. One of them is Azure Data Lake storage. These are stored as CSV files in Azure Data Lake storage into different subfolders. Another option is Dataverse, or as old we used to say it, come on Dataverse. Now, these two are the two different options, which depends on the type of data flow that you create, and that would be the storage of that. Now, if you are using Azure Data Lake storage as the storage for Dataflow, does this mean that you need to have a Data Lake subscription? No, really. Especially if you are building Dataflow in Power BI. Power BI has a like space for internal Power BI data flow usage. So you don't really need to have a separate license for Azure Data Lake. It uses that space for building Azure Data Lake storage for the Power BI data flows. In Powerapps data flows, however, it's a little bit different. You either use Dataverse or you bring your own Azure Data Lake option. I'll talk about that a little bit later. So what is the point of doing the transformations in the cloud, storing it in a storage? Then the point is that Dataflow would become like a database, like a layer of data source. Power BI can use that as a source. In Power BI, you can say get data from Power BI data flows, Power Query data flows, Power Platform data flows, and any types of these data flows actually. So you are actually building an intermediate layer. Now, what are use cases of that? And after that, I'll show you a quick demo of that. Use cases, if we get back to that example I told you. So I have my sales PBIX file, my inventory PBIX file, but this time instead of really copying the code for product table or date table or any other tables that are shared between those two, what I do is I'll create that table in the data flow. So Dataflow actually processes that date dimension, process the product dimension or table. Source code is in one place only. Running it only happens in that place as well, not one per file. So that place is the single source of truth, single source of the code, and single source of the data for that specific entity. Now, all other Power BI files now can import data from there. Or if I also have Power Platform applications using that, I can also point it to that place as well. So it builds like a central place for all of my data integration and data transformation. It helps me to also have a faster refresh time, because in Power BI, if I'm doing really heavy lifting transformations, such as connecting to a huge data source, doing some merge statements, then grouping it, then aggregating based on it, filtering. Some of these transformations might take really long time. You might have a refresh time of over an hour for your Power BI desktop to refresh, which wouldn't really make it possible to do any development, because you have to, every time we have to wait for an hour to see what happens and then do your development time. Versus if you push the heavy lifting part into the data flow, the overall time is still the same, but data flow refresh can happen independent from your Power BI desktop refresh. Power BI desktop just import the data from that source, whatever it is, from that data flow. Your Power BI desktop refresh time would be much smaller. The data flow refresh time would be the rest of the time that is used there. However, the data flow refresh time can be also speed up with using some of the premium functionalities in the data flow. You can actually use this approach to create a data warehouse. Now, I use data warehouse term here. Some people don't really like the data warehouse term. They say, well, if you want to really create a data warehouse, you should use Azure Synapse, you should use Snowflake, you should use Azure SQL Database, and they're all right about it, right? I don't really mean data warehouse in huge scale. I don't talk about like billions of rows. I'm talking about a centralized data mart, a dimensional model. Don't take that name that much seriously. There are a lot of Power BI users, even Power Platform users, who don't have the luxury of paying thousands of dollars a month for Synapse, for Azure SQL Data Warehouse, for Azure SQL Database, for Snowflake, for all of these different cloud database technologies. However, they want to use these business applications in their environment. They can actually use simply that data flow to build that centralized data mart for them without paying that many dollars for setting up that environment. Of course, if they ever go to like huge scale of data, then they have to go and choose those technologies. But for a starting point, this can be a really helpful place to build your centralized data mart over there. Okay, now let me show you a demo and then we'll talk about data flow a little bit more in details. I have Power BI service logged in here. Data flow is a service only feature. You cannot create it in Power BI desktop. So you can only go to the Power BI website and create it. You can also do it in Powerapps. I'll show you that after this as well. In Power BI desktop, when I'm in a workspace, I can click and say, well, create a new data flow. Similar to many other things we can create there. A data flow can be created from some of your existing data flows, or you can create it from scratch, which I'm going to do that by adding new table. I'll start to build it from scratch. Now, this would bring the Power Query online experience for me, where I choose all the data sources from here. You can go to each category and choose the data source from there. There are plenty of data sources to choose from. For example, I can even choose SQL Server data source. This can be cloud-based data source, or it can be on-premises. If I choose on-premises data source, then I need to also set up the gateway for that and choose that connection. In this example, I'm not going to do that. I just go and select an Excel file from my OneDrive for Business, because that way I wouldn't really need a gateway for that. So I'll go and connect to OneDrive for Business for a second. Yep, here it is. Recently, one of the features is also that you can upload a file. I'm not going to demonstrate that today. I'm just going to look at this from OneDrive for Business point of view. So I'll select that table. I don't need any gateway connection or anything like that. I'll just click on next. This Excel file includes a lot of sheets. Power Query will scan that file and will list all the different data sheets in there for you so that you can select those that you want to import data from it. I'm just waiting for this to come up in a second. And if you have worked with Power BI desktop, you are familiar with how Power Query works. When you import data from a source, you select different options. Normally, it shouldn't take this much long. I think having Teams meeting at the same time would also affect this. Yep, okay, here it is. So I have a list of all different sheets in Excel. I can go and select some of these, for example, product table, product category table, subcategory table. By selecting each of these, I'll see a preview of data over here. I'll select sales table as well. Let's say these are tables that I want to select. Then I say transform data. This will load like about 100 rows of each table in Power Query data flow online. Power Query in Power BI Desktop loads normally about 1,000 rows. Here it loads about 100 rows. It applies some of the transformations by default, such as bringing the first row as column headers, changing the data type. Depends on the data source. It might come with some of those options. So here you can see that I have 4 tables over there, and I have this what we call it a diagram view of these 4 tables as well, which I can see actually where the data is coming from. Then it has been navigated to a specific sheet, first row used as headers, and then the data type change happens. This is what we call as Power Query steps, which actually shows us what transformations has been done so far, and some data profiling information here that shows us actually what is the nature of data in every column. So here I have these tables. I'm going to do some very simple transformations just to show you how this works. I'm not going to, let's say, explain Power Query. That is totally different session to go through. So what I'll do is I want to combine these 3 tables together, product, product category, and subcategory, and build one product table and use that in my model. To do that, I'll merge this query as a new query with product subcategory. I would say, well, product subcategory key here from product and product subcategory key here. These 2 are my merging key columns. And you can see that I can choose also the join kind, like is it left join, right join, and you see what that means. For example, if I want all records from the first table, even those that exist in the second table, but not the second table, I choose left join. But if I want all records from both tables, I choose full join. If I want records that exist in both tables, I choose this, right? You can choose fuzzy merge if you are merging based on text field and things like that. I'm not going much into the details of that. So I'll just continue with this. This merge happens, and the diagram view also shows it really nice. You can see here that this new table called merge is coming from the in product and in product subcategory. And I can see that merged result from the other table over here. I can expand it and say, well, from the other table, give me English product subcategory name and product category key. And I'll select that. So this gives me those 2 columns. Now I'm going to only keep those columns that I need. I don't really want all these columns, so I select this one, these 2, and the last 2. And I'm going to remove other columns. You see, these transformations are really simple. Just right click. Everything is graphical. I can rename these columns just like that. For example, this would be product name. This would be subcategory. These are really simple transformations. You don't even need to write a code for that. And I'll leave that as product category key. Now I use that to connect to the product category as well. So I'll do one more time merge. This time I merge it with product category, and based on product category key here and product category key there. Again, I'll leave it as the default join criteria. After the join, I expand it and say, well, give me the English product category name. So category was in one table, subcategory was in one table, and product in one table. Now I combine them all in one. So this table includes actually all of those information. I'll rename this category column as well. Just category itself should be fine. There it is. And I don't need this extra key column over here. So this is my table. Really simple build. You see it has a lot of null values. That is because there are many products that doesn't have subcategory and as a result category as well. But in this value distribution chart, you see that there are other values in there as well. And this nice diagram view actually shows it all. It shows that this table actually comes from three other tables. At first, we merged these two, dim product subcategory. We expanded the result, selected some of the columns, renamed, then we merged it with another table, dim product category, and then a little bit further than that, we did some other transformations. Let me just change this and disable column profile because I will have more space to show you that. Okay, here it is. Now I did some other transformations. I can click on every one of these steps and see the data at that particular point of the time, like this was before merging to the third table. This is Power Query, very powerful data transformation engine used for data integration a lot. Now I can rename this table. Instead of merge, I can call it product because that is my product table. I can put those three tables that was for like before building this product. I moved them to a group and I call this group product tables, let's say. So those goes under that. I don't really want these tables anymore because everything is in that final product table. I'm going to just like disable the load of those. This means that they are not loading themselves, but the result is loaded into the product and product will be the one that is loading. I can put these two also in another folder and I can say, for example, there's a folder for my final tables or queries. This is up to you. How do you really decide to organize your table structure and anything like that? I can also build a table by just copying and pasting a script here. For example, I can say new query from blank query. This time I have actually a script which I can use. This is a script for creating a date dimension. You can download it from Radical website as well. I can just paste it here. This is copied from a Power BI desktop. I can paste it here. I can set the start and end year and things like that. If I click on next, this creates that table. This is another way to create it, and it includes a lot of steps. Of course, this one using some of the functions. So this is my date table, let's say now. So you either can do your transformations from the beginning and build it here, such as product table or sales table that I did, or you can just copy and paste from Power Query in other environments, in Excel, in Power BI desktop, and bring it here. Once you build that data structure you want, you can say, well, I'll save and close this one. You set a name for that, of course. Every data flow looks like a database, let's say. I can set a name for this. Let's say call it NZ Embass data flow. And I can refresh the data. So I refresh the data manually, but in general, you set it to be refreshed on a scheduled basis, of course. While that is getting refreshed, I want to also show you that something like this is also possible in Powerapps Portal. In Powerapps Portal, in the same place that you do all your data configuration, or let's say your Dataverse setup, you have the data flow. And you can go there and build actually a new data flow. You set a name for this. This time you first set the name and then you build the other thing. That is the big difference from Power Platform data flows and Power BI data flows, apart from another big difference, which one of them is purple, another is yellow, of course. So let's say that I call this one also Embass Power Platform data flow. Now I'll talk about what that analytical entity is in a second. So for now, don't worry about it. You see, it's exactly the same experience, different color, of course. I can choose exactly the same thing, Excel file. So it's all exactly the same experience. You have it in here, you have it in Power BI as well. Now, I'm not going to build that totally in Power Apps because it's exactly the same thing. I'll go to my Power BI desktop environment and I say, well, I want to get data from that Power BI data flow. That way, actually, I use the result of that data flow as like a database, as a source. I import data from there. So I'll go and select that data flow. It was in this workspace, I think. And I think I called it NZ Embass. Yep, here it is. Each data flow looks like a database, as you can see it here. I have different tables in here. Now I have the choice to select all the tables from this or just select a couple of this, for example. I'll select product table, I'll select fact internet sales table, but let's say for just to show you that it is possible, I can select the date table from another data flow, right? Of course, when it is there, I'll select it from there, but just to show you that it is possible to import from multiple places, I'll load it from another place, and I can load it over here. And then after loading these, the transformation here would be just importing data. I don't really build that product table. So all of those steps to transform that product table, all of those many steps of combining three tables together, they don't exist here. I just get the final product table as it is built in that data flow. If I go to transform data here, my product table is already those columns that I wanted to be. I'll go just a little bit down so that you see these values are not all nulls. So here it is. That's my product table. As a data modeler, I don't really need to know how this product table is created. Someone created that for me. Let's say the ETL developer, the data integration developer, they built that table for me, and I can go and use it. I don't have that source code of building that table. If I ever want to change it, I can easily ask them, well, go and apply some changes and give me the updated, and I will always use that updated data. Now I can save this and publish it. Let's say I publish it, and of course I would save it in my documents. Let's call it nzmbas dataset. Now this doesn't really have any report, but let's imagine there is a report. I publish it to just to the same workspace. It can be published to another workspace as well, but I just publish it to the same workspace for simplicity so that you can see both in one place. So now I have my data flow, build the database, the data storage, the central data model, and then dataset gets data from it. I'll go to here in Power BI website to that in BAS. Yeah, here it is. I have a dataset and I have a data flow. And if I click on these and say view lineage, I actually can see that how they are actually created. So I have the data flow coming from that Excel file which lives in my SharePoint folder. Then I have a data set sourced from there, and then I have a report sourced from the data set. So I have like layers of implementation in this. This data set can, of course, get data from other data flows as well. In this case, it actually does. Remember, I said that this date table comes from another data flow. So here you can see it actually. This gets part of data from one data flow, another part of data from this data flow. So you see actually the layered implementation of a data flow in this environment as well. So back to the slide. I don't see any questions yet. I can continue with the presentation, but if you have a question, can go through that or not. I'll just continue. We'll keep the time to the end if there is any questions on that side. So that is overall about data flow. You learned what it is, what is the use case of that. You've seen a couple of examples of it. Now let's talk about more details of it. So first is that data flow is not just for Power BI. It is also for Power Platform. You've seen it. I showed to you that in Powerapps Portal you can create data flows as well. The licensing would be slightly different, similar to the licensing of Power BI and Power Platform itself. They don't use the same licensing plan. Each of them have a different licensing structure. So, but it is possible to create it in both of these places. There are slight differences in how things work in one over the other. I'll explain that a little bit further as well. Now, to learn that, first you need to learn what are these types of entity. Each entity is actually a table in data flow. We call it entity, sometimes we call it table. There are three types of entities. One is standard entity, which is created just normal, importing data from a data source. computed entity, which is an entity that is created from other entities. If I have product table, let's say it this way, if I have product and product category together merged to build a third table, that table is a computed entity. It comes with that lightning icon beside it. A computed entity normally performs faster because it loads the result of the other two rather than connecting to the source all the way and populate the data from there, and then do the rest of transformations from there. Computed entity is a Power BI only feature. It does not exist in Power Platform data flows. However, there's a workaround in Power Platform to create it, like if you are using command data, I used to say command data service. If you are using Dataverse, then you are importing that data into a table. Other tables, when they get data from that particular table, it's like computed entity. Now in Power BI, computed entity also comes with some enhanced functionality, something called enhanced computer engine, which loads that compute entity into a Azure SQL database background, which speeds that up, brings some parallel processing and things around it. Unfortunately, we don't have that in Power Platform data flows, but who knows, we might have something like that in the future as well. Computed entity is a premium only feature in Power BI. So if you are using Power BI licensing, then you need premium or PPU, premium per user, for that. Linked entity is an entity that actually exists in another data flow. You just bring it into this data flow to have it beside other entities in this data flow. This linking this to the other data flow doesn't really mean that you are creating a copy of that in this data flow. It's just a link. That is why it's called linked entity. You cannot even transform it. You cannot even change it. It's just a link to that source entity. This is also a premium functionality in Power BI. There are workarounds for creating this without premium license, and I have written blog articles about those as well. Now, if you remember, when I showed you that data flow in Powerapps Portal, there was a checkbox that do you want this to be created analytical or not? Now that is the point to answer. Right now is the point to answer that question. What is analytical data flow? What is standard data flow? So data flow in general is what you have learned so far. There are two main types of it: analytical, standard. Which really depends on what functionalities you want in your data flow. Analytical data flow gives you some additional analytical features, such as AI functionalities. And the storage is optimized for analytics, Azure Data Lake storage, versus standard data flow stores data in Dataverse. So if you create a data flow that stores data in Dataverse, that is a standard data flow. You cannot perform AI functionalities on that, not as a built-in data flow features. There are always workarounds. If you create it as a Azure Data Lake storage, then it is an analytical data flow, which comes with computed entity and AI integration as well. Standard data flow comes into different variations as well, V1, V2. I wouldn't go really into the details of those two. It would be too much details for this type of session, which is more like a overview of data flows in general. Now, this is also more explanation of what are the differences between analytical data flow and a standard data flow. I would say like two different scenarios. I would say one scenario, if you are building a data flow that you want to reuse the result of that in multiple, let's say, platforms. For example, you want to use that table in Power Apps and also in Power BI. Then standard data flow might be a better option. And let's say you don't really need that much AI functionality in that case. But if you are building something only for the Power BI use case, and you also want AI functionalities, then you are getting much more value from an analytical data flow, which can be, of course, created in Power Platform data flows or Power BI data flows. A standard data flow can be only created in Power Platform data flows. You cannot create a Power BI data flow, which is standard. That is only available in Power Platform. Storage options. I said that we have two options for storage. One is Azure Data Lake storage, another is Dataverse. If you are using Azure Data Lake storage, then you also have two more options. One is that you can use the internal Azure Data Lake storage, the one that Power BI or Power Platform gives you that capacity, or bring your own data lake storage. If you use the internal storage, then you cannot really use that storage or connect to that storage from other places. Like you cannot open Azure Data Explorer and go and see what the data looks like in that storage, because that is not really your storage. It's just a shared storage that Power BI uses and give you access to that only through the Power BI service application. But if you bring your own data lake storage, then you can really connect to it from other applications, and you can see what is the structure of that storage in there. That structure includes subfolders, like you have one folder for every workspace, or let's say environment, and then one data flow, one subfolder for each data flow. And in each data flow, you also have subfolders for each entity. In each entity, you might have multiple CSV files for that entity. That is how it works. Inside data flow, you also have a JSON file, a metadata JSON file, which includes basically everything that data flow does. All the tables, the M script, Power Query scripts that build that actually data table in data flow, the relationships between data tables, the data types, everything is in that JSON file. You can export that JSON file from a data flow. I'll just show it to you very quickly. Like if I have a data flow like this, I can go and export the JSON file for that. This JSON file is the metadata for this data flow. That includes everything. If I want to give you the source code of this data flow, that is where that source code is, this metadata JSON file. And once you have it, you can actually build a new data flow right from this. And when you build it, then you just have to refresh it so that you get the up-to-date data from it. Otherwise, that is the code of this data flow. Going back to presentation. Okay, best practices. So you learned about Power BI, Power Platform data flows in general. You've seen that, how they can be used. You've learned some of the details of that, standard versus analytical, the data flow that can be created in Power BI environment versus Power Platform environment, and things around it. Now, how you really use it in a solution. Do you just like create a data flow, put everything in there, or do you separate it? So let's talk about some of the best practices options. First option is to use computed entity as much as you can. Computed entity is when you have a set of shared transformations between two tables and you put them in one table and then you reuse it in other places. So let's say I have this table, query 1, connecting to the data source, applying some transformations, then building this. Query 2, connecting to the same data source, applying some transformations, building this. Now, some of these transformations might be really like shared transformations, but in this case, they are processed totally separately. If I can find what are those shared transformations, I can do it this way. I can connect to the data source, do those common transformations or shared transformations, load it into the destination, Azure Data Lake storage. Then those two queries, they can connect to this data flow entity rather than to the source itself. That is the help of computed entity here, that you don't really redo those transformations per each of these tables. You just use the result of there and then build on top of it. That is why it makes it faster. Break your data flows into multiple data flows. Don't put everything in one data flow. Create a layered architecture. Always layered architecture helps. Like, for example, have a staging data flow and transformation data flow. Staging data flow is just like ingesting from the source without doing any changes, and then transformation data flow get the input from staging data flows, which is just staging from the actual data source, and then do the transformations on top of it. There are many benefits of it because like you can easily change one over the other if your data source changes. For example, if it was Azure SQL database, let's say if it was Oracle on premises, then you change it to Azure SQL database. Then all you need to change is your staging data flows. Your transformation data flows wouldn't really change. If you are applying a transformation, you need to just go and change transformation data flows. You don't need to touch your staging data flows. Makes it much easier to maintain in the future. Same thing can be used for slow data sources. Let's say I have an on-premises data source such as DB2. It is very slow. Every time I create a connection to that using a gateway, it would take a lot of time. If I have 3 data flows populating information from there, it would take like forever. But if I have just one data flow connecting to that, ingesting the data that I need for others into this, and then other data flows get data from this, that would make it much faster. So using that layered architecture, I make it much better in terms of performance and usage. Another use case of data flow is using it for data source isolation. That is a really big concept in all the BI and analytical solutions, and that is saying that we separate the analytical solution from data source as much as possible, because then we are not dependent on the data source. How this is helping? Imagine this scenario. Let's say I have a database table with billions of rows and some Power BI files, building reports and analytics on top of that. This can be enhanced much better if I build a data flow layer in the middle that populates data from there, but not all that billions of rows, only filtered data for as much as I need, aggregated in the level of that I need, and then Power BI desktop reports populating data from there. So only the data that I really need, not that billions of rows. This can also help in terms of read from the source system as well. If it is a highly transactional database system, a lot of systems depending on it, so then I wouldn't really want every single Power BI report to have a lot of read transactions from it, because it might create a bottleneck for that. What I'll do instead is I create a data flow layer in the middle, importing data from that source. Read only happens for this, and then other Power BI data sets just read from that data flow storage. Security can be another challenge as well. Instead of going and setting up a lot of security control levels of access in the data source and then giving access to the Power BI desktop, I can build one security configuration for the data flow, and then that inside data flow, I can define as many as security access to the subtables that I want for the Power BI desktop or data sets files. So there are a lot of actually usage of that. I wrap this up with this final explanation of the architecture that I usually advise for working with the BI solution, no matter Power BI or other BI technologies you are using, and that is a 3-layer architecture that we always use no matter what technology is. Having multiple layer in a BI system or any development system actually makes that solution multi-developer. Power BI, if you just use a Power BI just as it is, if you build everything in one Power BI file, one PBIX file, it is possible. It is possible for you to connect to the data source, to do all the data transformation in one file, write your DAX calculations, create relationships, build your report, everything in one file. It is possible. But the problem is that if someone else also wants to change it at the same time that you want to change it, that is not possible. Multi-layer architecture is the first step towards multi-developer environment. If I separate my implementation into multiple layers, then I can have multiple people working in that layers. For example, I can have my data transformation layer separated using data flow. Data flow connects to the data sources, whatever it is, Excel, CSV files, SharePoint, Azure SQL database, anything. Apply the data transformation, then stores it in data flow storage, which can be Dataverse or Azure Data Lake storage. And the person who is working in data flow is more like a data engineer. This is a person who understands Power Query. This is a person who can write M scripts. This person doesn't really need to know how to write DAX expressions. That is the next layer. The next layer is someone who understands the relationship in Power BI, can write DAX expression. That person gets the data input from the previous layer, from the data flow, and builds the relationships, data mart, such as sales data mart, inventory data mart, with the tables coming from data flow, writing DAX expressions and calculations for it. This person is a DAX developer mainly. And then this dataset, once published into the cloud, then report developers can connect live to that dataset and build the reports. You can have like 10 different report developers connecting to the same Power BI dataset. Report developers doesn't need to know DAX or not even Power Query. They just build the graphics and visualizations of the report. Another beauty of this multi-layered architecture is that you can easily replace one layer with another technology. For example, if you ever want to change data flow, Power BI data flow with Azure Data Factory wrangling data flow, you can go and change it. It wouldn't hurt the other two layers. If you want to change your Azure your data Power BI dataset layer with Azure Analysis Services dataset, you can easily change it. It wouldn't hurt the other two layers. If you want to change your visualization instead of Power BI to be Tableau, to be paginated reports, to be anything else, then you can change it as well. This multi-layer architecture is not just for multi-developer, it is also easier to maintain moving forward as well. Talking about that architecture, it also brings this concept that workspaces and their design is quite important. You can't put everything in one workspace. We usually create workspace per user base. Like, for example, if I create a set of sales report for sales users, I create a workspace for that. If I create a set of HR reports for HR users, then I create a workspace for that. But these two workspaces, they might use some shared tables, such as date table, currency table, time table. I can put them in some data flows in another workspace that these two workspaces are actually having access to that. So I kind of create that hierarchical structure. This hierarchical structure can go to another level as well. Some of the tables can be used in all other workspaces. Some of the tables can be used only in few workspaces. For example, account tables are not useful for HR workspace, but for sales and accounting, right? You create this hierarchical layer of the workspace, designing workspace and designing your data set and designing your tables and data flow. These are all bound together. When you build the solution, you have to think about designing all of these as one big architecture design rather than designing each of these separately. One last thing that is coming about data flows is that data flow would be available to be used as a source in Excel as well. That is coming very soon. I don't really have an exact ETA, but it would be available very soon. Power BI team are working on it already. That's pretty much everything I wanted to say. If you have any questions, I think we have quite a lot of time. And thank you again for watching.
Thank you, Reza. I'm not sure if you seem to have any questions at the moment. There was just like a flood of information. There was so much. Thank you so much for that. That was awesome. Especially, I really like the way that you kind of shared your, I guess, your architecture best practices as well. I think, you know, setting things up right from the start is so important.
Yeah.
And it's been really interesting. you're watching the other kind of Power BI related topics, everyone's kind of touched a little bit on architecture, and how to set things up. So, yeah, thank you for sharing all of that.
You're welcome. Thank you for the opportunity.
No worries. All right, last call for questions here.
Thank you, Sarah, and thank you, Anish. Great.
All right, well, we'll take a break for 10 minutes, and we're going to be back here at 2 o'clock. I think Suhail is going to be going on about Power. We're keeping on with the Power BI theme here and getting into governance, which there was kind of a few questions we've had earlier sessions around that. So looking forward to that session, and we're kind of going into a bit of a Power BI merging into a governance track this afternoon. So stay tuned for all of that. I'll see you back here in 10 minutes.
Thank you.
Yes, thanks for that.
Have a good rest of your day, everyone.